Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today in our lesson, we're going to focus on electrochemistry. So it means we'll be doing both question 8 and 9. Now we won't be necessarily be teaching you, but we will be doing revision. So we're going to focus on papers from other provinces that they wrote now during the prelims, so that you can prepare yourself and be ready for the final exams. This is question 8 and 9 under chemical change, and we're hoping that you are going to get as many marks as possible. As you know, paper 2, we are saying we have 10 multiple choice questions and 20 marks. The structure of the paper, as well as structured questions, we are saying is 130 marks. The total of the paper is 3 hours. You're going to write for 3 hours out of 150 marks. And then if you can look, the first part of our lesson, we'll be focusing on galvanic cell. The main thing here, the issue of definitions. Remember, we're always saying use the exam guideline to define. So we are saying continue to use your exam guideline for your definitions so that we can be able to move forward with no problems. So you will tell us what is oxidation. I think by now you know that loss of electrons is oxidation. Don't forget that. And we are saying you must know what is a reducing agent. We are saying a reducing agent is a substance that undergoes oxidation. And you must know that that substance that undergoes oxidation, the reducing agent, is oxidized, or its oxidation number will increase. So if you want to check whether a substance has lost electrons, it means you will see that the oxidation number will increase. And then reduction, we are saying this one is the gaining of electrons, which we call reduction. So a reduction is gaining of electrons, which is reduction. And that's where we find our oxidizing agent. So if we say what is an oxidizing agent, you will say it's a substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. So you know that that is your oxidizing agent. So always remember those mnemonics that we are using there for you to be able to remember these definitions. And we are saying you must know what is an anode and what is a cathode. As we always emphasize that you can look at there for galvanic cell, an anode as a negative electrode. A negative electrode, and definition of an anode we are saying is an electrode where oxidation occurs. So it's an electrode where oxidation occurs. Hence we say an ox, so that you don't forget. So we're saying an anode is the electrode where oxidation occurs. And we are saying a cathode, we write cathode with a positive there, so that you don't forget that a cathode is a positive electrode. So this one we're saying is an electrode where reduction takes place. Hence we say red cat. The red cat is there to remind you that at the cathode, that is the electrode where reduction occurs. And we said reduction is gaining of electrons. So we always want to ensure that when it comes to definitions, you do very well. Now, the definition of an electrolyte, you'll find even in the question papers that we're going to deal with today, you'll find that you'll be asked to define what is an electrolyte. And we're saying this is a substance that has been dissolved in water. And when it's dissolved in water, it forms ion, and it forms ions in the solution, and that solution can conduct electricity. So you can say this is a solution that conducts electricity through the movement of ions. So you are able to define that according to your exam guideline. You are able to define electrolyte. And we are saying you must be able to know the relation of current and potential difference to the rate and equilibrium. So hence when you look at the tables, you will have seen that we are having those reversible reactions. That shows you that we are talking about equilibrium here, and then hence we will refer to equilibrium. When do we say we are reaching equilibrium? Remember, we are saying that at equilibrium the EMF of the cell will become zero. And then we are saying you must be having understanding of the processes and redox reaction itself, which is mostly what you did in grade 11, where you define redox reactions as the oxidation reduction reactions that you have done there. You were using the oxidation number. So it's very much important that that information of oxidation number, you keep it alive. Remember, If you are having magnesium, for example, as Mg, you know its oxidation number is 0. But when you have Mg2 plus, its oxidation number is +2. And always remember the issue of oxidation number. So we are saying before you do that, the last thing is the standard electrode potential. We will ask you to calculate the standard electrode potential for a substance, or we'll ask you to calculate the EMF. So what am I saying here? I'm saying some of the time will give you E of a cell, which according to the data sheet is E cathode minus E anode. You will see in the next slide, I think we're going to get that formula. And then we are simply saying that now this E of a cell, some of the time, will give you E of the cell, which will refer to it as initial EMF of the cell. So we'll give you the initial EMF of the cell and give you either the cathode or the anode. Then we ask you to identify the other electrode. Or we'll give you the cathode and the anode, and then you are able to calculate. So always when you're dealing with the questions, check what you are given. Am I given the cathode and the anode, or am I given the EMF and 1 between the cathode and the anode? Then you are able to calculate the other one. So that is very much important. So we'll be using the table of standard reduction potential. Remember, we have table 4A and table 4B. We'll go through them so that we remind you what this table mean and how you must use them to answer questions. Now, we have done the definitions already, so I won't spend time much here. We define loss of electron as oxidation. We said that is the reducing agent, which we said is the substance that undergoes oxidation, and that substance is oxidized. So we did that, and those are the definitions that you will always remember. We talked about gaining of electrons. We said is reduction. We said the oxidizing agent is the substance that undergoes reduction. A substance that undergoes reduction, we said that is our oxidizing agent. Now you can see that a substance is oxidized when it loses the electrons. So just in real sense, we're saying the oxidation number increases. We refer to that as being oxidized. For example, I've shown you magnesium to say when magnesium loses 2 electrons, it's now oxidized. So when you say it's oxidized, we're saying that its oxidation number has increased. But if we are having, for example, zinc 2 plus gaining 2 electrons to form zinc, we'll say that zinc 2 plus gained electrons and it was reduced because it's starting with a +2 and ending up with a 0. So we have those two processes. We're saying they take place simultaneously, and you must know all of them. So we've done all these definitions, and I'm hoping that by now you understand the definitions. The other thing that I want to emphasize when we start with this lesson, have your table. Remember, at the back of your question paper, you are expecting to have your table 4B and your table 4A. So have those tables so that you are able to utilize them as we'll be doing our calculations, and have a calculator next to you because we'll be doing a lot of calculations when it comes to E-cell and when it comes to stoichiometric equations that we will do. You will have seen that now there is stoichiometry in almost all the questions that we are doing. So it's important that you always prepare yourself to say that we are going to do some calculations even in question 8 and question 9. So I hope that helps you and prepares you, and you are ready with your table 4A and table 4B. You are ready with your calculator next to you and a notebook where you will be writing some notes as we continue to do this lesson. Now, how do you use the data sheet to remember definitions? Remember, already we told you that the EMF of the cell is E cathode minus E anode. This is the data sheet for this particular question. So you are able to know that, okay, for the cathode is here with reduction. So hence we said is an electrode where reduction. Okay, so you can see already that this table helps you, this data sheet helps you to remember that a cathode is the electrode where reduction occurs. For example, if you are saying what is oxidizing agent, you are able to say oxidizing agent is a substance that undergoes reduction. If we are saying what is a reducing agent, you are saying it's a substance that undergoes oxidation. What is anode is the electrode where oxidation occurs. So you are able to see that all this helps you with the definitions, and we are expecting that you won't be losing marks on definitions. If you have forgotten any of this, you can come to this table and it will help you with some of these definitions. And we are hoping that you will collect all the definition marks as we emphasize. As I indicated, we're going to focus more on provincial papers that were written on question 8 and question 9, because by the end of this lesson, we want you to know the different ways questions are asked and different ways to respond to such questions. Now, our first questions will be based on galvanic cell. After that, we'll go and do questions that are based on electrolytic cell. Now, when you look at your galvanic cell, we're saying a piece of magnesium ribbon reacts with excess hydrochloric acid according to the following balanced equation. We are saying now a piece of magnesium. So you can see it's magnesium, and if you look at this, you will have seen this type of reaction when we're dealing with rates of reactions. So you can see that these reactions, same reactions can be used in rates of reactions, and it can be used in redox reactions. Now, if you look at this, we're having magnesium solid. So if we're talking rates of reactions, you will have seen that we have the surface area. We must have the mass of magnesium because it's in a solid form. And we're having hydrochloric acid, which is an aqueous solution. And you know that for aqueous solution, we talk about the concentration. So you can see that already here we're having magnesium ribbon, which reacts with excess hydrochloric acid according to this reaction to form magnesium chloride and hydrogen gas. Now, the question is saying, which one of the following is an oxidizing agent? Remember, by definition, when we started, we said loss of electron is oxidation. That's where we find our reducing agent, and reducing agent is oxidized. But for the oxidizing agent, we said gaining of electrons is reduction. That's where we get our oxidizing agent, and our oxidizing agent will be reduced. So it's very much important to know if we are saying which one is the oxidizing agent, we are saying which one will be reduced in this reaction. So we're going to look at the reactants. Remember, our agents are on the left hand of the equation on the reactant side. So it means this is an agent and this is an agent. Remember, the reaction happens between a stronger oxidizing agent and a stronger reducing agent. So always when you look at an equation like this one, you will know that here on the left, we have stronger oxidizing agent and stronger reducing agent. And if you have seen on the table of standard reduction potential, you will have seen where you have these metals, magnesium, zinc, copper. That side, you will have seen there is an arrow there. I will show you when you deal with the table. There is an arrow there that is pointing upward on table 4B. That shows that increasing, reducing ability. So you know definitely that magnesium or these metals are more likely to be your reducing agent. So you know that your magnesium will be reducing agent. We're going to look at that. Then let's check. In this question, what are you going to do? You're going to use oxidation numbers to answer this question. Already, we are saying that when magnesium is alone, its oxidation number is 0. When you are having HCl, you know hydrogen is a group 1 element. So we are saying that it has positive 1. Chlorine is group 17. So you know from chlorine group 18 elements, we're saying the oxidation number there, we're saying our charge there will be 0. And then group 17, it will be -1. Group 16, where oxygen is, will be -2 as we come backward to nitrogen, which will be -3. So you're able to check which oxidation number are we supposed to give to hydrogen. As a group 1 is positive 1. Chlorine group 17 is -1. So you're able to put the oxidation numbers there. We go to the product side, and you see that chlorine, we said, is -1, but we have 2 chlorines, which gives us -2. So you can see that magnesium is +2. So in this case, magnesium has increased. The oxidation number of magnesium has increased from 0 to +2. So you can see that magnesium has lost electron. It has underwent the reaction called oxidation, which means magnesium is our reducing agent because it is oxidized. So oxidized simply means that its oxidation number has increased. So you can see that magnesium in this case is a stronger reducing agent, which means now between hydrogen and chlorine, we're going to look for our stronger oxidizing agent. And if you can check there, you are able now to check to say, okay, what is happening here? Hydrogen is +1, but hydrogen on the product side is 0. So you can see that hydrogen has changed from +1, from H plus to H, which is H2. So this is 2H plus to H2. So you're able to see that our hydrogen changed from H plus to H0. So you know that we have 0 there. So which means now that H plus or hydrogen ion has gained electrons, is undergoing reduction. And indeed, hydrogen ion were decreased from oxidation of +1 to oxidation of 0. Hence, we are saying oxidizing agent must be reduced. So you see that H plus has been reduced to 0. So with confidence, you are able to say our oxidizing agent, the one that gained electrons, the one that is undergoing reduction, is our oxidizing agent, which in this case is reduced from +1 to 0, which is hydrogen ion. So with no doubt, you are able to choose and get 2 marks to say the oxidizing agent is this one. So our oxidizing agent, you will see that is mostly positive because it is more likely to gain electrons. It has higher ability to gain electrons than the reducing agent. So I hope you got that and you'll be able to utilize that. Now they are saying in a galvanic cell, the salt bridge is responsible for. So remember, this question is here to remind you of the functions of the salt bridge, to say what do we use the salt bridge for. Remember, we use the salt bridge to complete the circuit, and to maintain electrical neutrality. How do we do that? Is by allowing to ensuring that where we have more negative, that's where our cations will move. Where we have more positive, that's where our anions will move. So you are able to know that, okay, a galvanic cell is responsible to maintain the charge balance. This is the neutrality we're talking about, the charge balance in the cell. How is number B wrong? Number B is saying it allows for the movement of electrons. The salt bridge is not where the electrons move. The salt bridge is where the ions move. The cations and the anions, they move in the salt bridge to maintain electrical neutrality. So this number B is wrong because it's not the electrons that move. Number C, it says the salt bridge, the salt bridge allows the mixing of the two solutions from different cells. No, that's not what we're doing. We're not mixing them, but it's maintaining neutrality. And then it's saying, number D, the salt bridge is not necessary for the optimal functioning of the cell. This statement is wrong. Remember, without the salt bridge, the cell is incomplete. So 100%, number A is our answer, is there to maintain electrical neutrality by maintaining the charge balance in the cell. So that is the 2 marks that you got for that question. Now, let's look at the galvanic cell. They are saying the following balanced chemical equation represent a reaction when a galvanic cell is operating under standard conditions. Immediately when we tell you under standard conditions, you know that there might be a question that we might be asked about standard conditions. Remember, we have 3 standard conditions. In this case, we used to say when we're dealing with factors affecting equilibrium, we said there are 3 factors that affect chemical equilibrium, and you said it's CAPTA, you said it's CPT, which is your concentration, your pressure, and temperature. Here I want to emphasize, please don't write the conditions as concentration, pressure, and temperature. No, you must always write them with the values to say how much is the concentration, how much is the pressure, how much is the temperature. So in this case, the concentration, remember, concentration affects gases and aqueous solutions. So we must have gases here for concentration to affect, and you can see we have aqueous solutions and gases. Definitely concentration is a factor, and we are saying initial concentration of 1 mole per cubic decimeter. Pressure affects only gases, so there must be a gas that pressure can affect there. So I would always advise you when you're writing the factors to start with temperature and concentration, those two, because those two, they affect all the other reactions that we do. But if you check pressure, it only affects when we have gases. So let pressure be your number 3 in terms of writing the factors that affect or the standard conditions. And we're saying pressure is 1 atm, or 1, which stands for 1 atmospheric pressure, or you can say 101.3 kilopascals. Your temperature, you will say 25 degrees Celsius, and you can as well say 298 kelvins if you want to use the Kelvin scales. So that is the question that is asked there. Write down 2 standard conditions under which this cell operates. So you are able to say concentration of 1 mole per cubic decimeter, initial concentration of 1 mole per cubic decimeter, temperature of 25 degrees Celsius. Now they say for this cell, write down the name of the formula of the electrolyte that can be used in the salt bridge. Remember, in the salt bridge, we need a salt, but we need a salt that can dissolve, that is soluble, that can be able to dissolve in water, that can be able to form ions, because remember, we want the ions to be able to move there, because the salt must be able to form the cation and the anion in order for it to maintain neutrality. So you can choose any salt that is that can dissolve there. You can use potassium nitrate, for example, as your salt, because potassium nitrate can form a cation, which is K plus, and an anion, which is NO3 minus. Remember, learners, the cation would always flow towards the cathode. The anion would always flow towards the anode. For both these cells, you've got to have that understanding that cations will go towards the cathode and ions will go towards the anode, because this is a negative electrode. Then the anions will go there to maintain neutrality. So please don't forget how the neutrality is maintained. Now the next question, they say write down the reducing agent. That is question 8.2.2. Write down the reducing agent. So you are able to look into that question and say, what is the reducing agent? Remember, the main thing that helps you, you know that the reducing agent, we said, is that one that loses electron, undergoes oxidation. We call it the reducing agent, and the reducing agent is oxidant. The one that gains electrons undergoes reduction. We call it oxidizing agent, and that one is reduced. But this question said we're looking for the reducing agent. So you look for the one that is which one is going to lose electrons. And I want to give you a tip. You see, we have chlorine, which is minus, and we have gold here, which is with an oxidation number of 3 plus, Au 3 plus. So you got to have the understanding here of saying, okay, fine, when you're having Au 3 plus, this Au 3 plus is it's a stronger oxidizing agent, because it's more likely to gain electrons. Because when it's a 3 plus, it shows that it became 3 plus by losing electrons. So it's a stronger oxidizing agent, while the chloride ion is your stronger reducing agent. Remember, we said on the left of the reaction, or on the reactant side, we always have a stronger reducing agent and a stronger oxidizing agent. So you won't forget that. So our reducing agent there will be Cl minus, or you can say chloride ion. I've seen that majority of our learners, they will write chlorine ion, which is not correct. It must be chloride ion. The best way, just write Cl minus. We will be able to give you 1 mark for writing Cl minus as your stronger reducing agent. Now they are saying here, write down the cell notation. Write down the cell notation. Remember, for cell notation, we are saying you can say all clever learners. All clever learners. So you say all clever learners. Or you can say A, B, C. The A stands for the anode. So you must always start with the anode, then the salt bridge, then the cathode. Here you have already showed is the anode, the salt bridge, and the cathode. Always in that order. So already you have seen that at the anode side, because you have seen that you said chloride ion is the reducing agent, which means it's the one that is going to lose electrons. So chlorine ion is going to lose electrons, so which means we're having that Cl minus becoming Cl2. So that's 6 Cl minus becoming 3 Cl2. So that's how the electrons were lost. So the anode, we are losing electrons. Where we have loss of electron, that is our anode. So which means here you're going to have chlorine minus, becoming Cl2. So you put a solid line between them because these two, they have different phase. That solid line shows that they have different phase. Remember, if all of them were aqueous solution, for example, same phase, you will just put a comma between them. But because chlorine ion is aqueous solution and Cl2 is a gas, you put a solid line between them because it's indicating that these two have different phases. And remember, chlorine is aqueous, Cl2 is a gas. So for us to be able to conduct electricity to allow the flow of electrons, we always need a solid. In this case, you're going to take platinum and use it as your solid. So when you don't have a solid, you are going to look for platinum to use it as your solid so that it's a good conductor of electricity. So your cell notation will start with platinum there because chlorine minus and Cl2, they are all not solids. We need an electrode must always be a solid. Hence, we are using platinum as our electrode there. And then you have your salt bridge. You can indicate the concentration of your solution to say your solution have the concentration of 1 mole per cubic decimeter. It's fine, but we don't penalize you for writing it in this way. So you are able now to say, okay, we've written on the anode side, you go to the cathode side. On the cathode side, we are saying Au3 plus is gaining electrons, gaining 3 electrons. So you have Au3 plus forming Au. Au is solid, so you don't need platinum there. So you will write your cell notation in that fashion. You'll see when I show you the memorandum. I just prefer that we first do it so that you see how you go about answering the question. The last question is saying, calculate the standard reduction potential of Au. Obviously, we're given the EMF as 0.14. So definitely you need table 4b, guys, learners, to be able to do this kind of calculations. This is table, hence when I started the lesson, I said for question 8 and 9, we'll need this table because this table is going to give us everything that we need. But remember, for this question, we are given that EMF of a cell is 0.14 volts. That was given in the previous statement. The EMF is 0.14. And chlorine, do you have chlorine on the table? You go to the table, you look for chlorine, and then if you check nicely, you are going to get your chlorine there. On the that will give you a Cl minus as your electrode there. So I just want to find it fast. Then you go to your table, you look for your chlorine, which is your Cl. There it is. Cl2, which is 1,36. Very much important. Now, we know two things. We know that chlorine, that we said is in the anode. We said our E anode, which is chlorine, we said is positive 1,36. So you're able to get those two. Then you can now be able to do the calculation because you now have to find your last electrode there, which is the gold part. To say the gold, how much for gold. And if you look for Au, you won't get it in this table. Hence, you were given the 0.14 so that you can be able to calculate it using the formula. Remember, you will go to the data sheet and know that you have E cell equals E cathode minus E anode. Then you are able to do your substitution of 0.14, and for your anode, for your E anode there, then you are able to get everything that you want. So if everything is done and done correctly, you will have had your E of a cell, which is E cathode minus E anode, or E reduction minus E oxidation, which is 0.15. That becomes E reduction minus 1,36, and when you transpose, when you bring the 1,36 the other side, it becomes 1,5 volts. So you are able to see that your gold there will have standard reduction potential of 1,5. It's important that you always copy these things correct, the formula correct. You can't do the shortcut of saying EOA or RA, all those things. You can't do that. You must definitely copy the formula the way it appears in the data sheet. I hope you got that one and it will help you moving forward. And you can see how we go about marking your cell notation there. We have emphasized the issue of platinum. When we don't have a solid, that you would use platinum as your solid. And we have emphasized the issue of the salt bridge there. And then we've emphasized the issue that outside we start with the anode. All clever learners. So like that, or say APC, then that is the way you will do it. I hope this question paper helped you to have understanding, and when you get questions of this nature, you will be able to answer them. Now let's go to the question paper adopted from the KZN prelim, which says a galvanic cell is constructed using lead, which is Pb, and magnesium. So we have lead and magnesium electrodes. The electrons will flow from there. Then you are able to check. The main thing here, remember, electrons always flow from anode to cathode. So that is the understanding. So this question is simply saying to you, between magnesium and lead, which one is a stronger reducing agent? So you see the importance of a table, because immediately when you go to the table, you'll be able to look for Pb and Mg for lead and magnesium and be able to check which one is a stronger reducing agent, because a stronger reducing agent is the one that will lose your electrons. So if I go to the table, yes, here we have a table. Sorry for that. If I go to the table, you are able to see that, okay, we're looking for magnesium and for our lead. So magnesium is there with a standard reduction potential of minus 2,36. So we're having magnesium with a standard reduction potential of minus 2,36. So now you check, you are looking for lead, which is our Pb. Then you are able to look for your Pb there, which is your lead as well. And then so it's important that you look fast, because time is always not on our side. So we're having Pb. You see, I want to emphasize this, that on the left here, if we check the arrow here, it's saying the arrow is facing downwards. It's saying increasing the arrow on the right. As we move to this one, we're saying increasing oxidizing ability. Yeah, the arrow is saying increasing reducing ability, which means on the left we have reducing agents, on the right we have oxidizing agent. Let me show you this, because this is important, and I think it's something that makes you understand this topic. Because we're saying we have Mg 2 plus 2 electrons. The way it's written like this, which is Mg with a standard reduction potential of minus 2,36. And we have lead that is written as Pb2 plus 2 electrons, forming Pb, and the standard reduction potential is minus 0,13. Remember, this table of standard reduction potential assists us to say the one with the highest potential. Remember, potential is ability. The one with the highest ability will undergo reduction, which means will gain electrons. In this case, the highest ability is 0,13. So you know that Pb2 plus is a stronger oxidizing agent, meaning that Pb2 plus will gain electrons. So we don't change this one, but we must write one arrow there. We don't write. Remember, when you ask you questions, there's nowhere where we expect you to write 2 arrows. You must write 1 arrow. In this case, we're saying for the strongest oxidizing agent, the reaction will remain the way it appears, but with 1 arrow. So I'm emphasizing that one, that Pb2 plus, because it's a stronger oxidizing agent, or it has a higher reduction potential, it will undergo reduction. Hence, you'll write it like that, but with 1 arrow saying Pb, which means Pb2 plus will gain electrons, meaning that the strongest reducing agent, which is magnesium in this case, because the arrow is going up, is showing you that between Pb and magnesium is the strongest. According to this arrow, magnesium is the strongest reducing agent. So there are 2 reducing agents for every reaction, but the other one is stronger than the other one. In this case, on the reducing agent, we are saying magnesium is a stronger reducing agent, because as you go up, the reducing ability increases. So magnesium is a stronger reducing agent than Pb, than lead, meaning that magnesium will lose electrons. And the question was saying, where will the electrons move? So you are able to see that the electrons will move from magnesium to the lead cell. So we go back to our equation, which now we know that, okay, the electrons, number C says magnesium half cell, the electrons flow from the Pb, lead. So these two are wrong because the lead is the, where we said it's not a stronger reducing agent. So it's not the one that will lose electrons. But magnesium half cell to the lead half cell. So we're agreeing that the electrons will flow from magnesium half cell to lead half cell. So we're agreeing on that one. Now the issue here is, are the electrons going to flow through the Sol bridge? I think we talked about this at the beginning of the lesson, to say the electrons, they don't flow through the Sol region. It's the ions. Remember we said it's the cation ions and the anions that flow through the Sol bridge in order to maintain neutrality. So magnesium half cell to the lead half cell through the conducting wires. Remember, with those conductors, that's where our electrons flow. So number D becomes your answer. I hope that question, it will help you and it will further increase your understanding of this topic. Now let's go to structured questions. They are saying the table below shows a half cell and an unknown cell B. You see, the importance of this activity that we are doing is that we want to do different ways that you will be asked the question, so that no matter how the question is asked. Remember, on the first question that we did, we were given the net cell reaction of 6Cl minus. You remember, reacting with gold, the Au2 plus. In this one, we're given half cell A, which is the silver half cell, silver plus and silver solid. So you have the aqueous solution and that one. But the half cell B, they are saying, is unknown. So sometimes we'll give you only one and not give you the other one, so that the questions will be about to finding, how do you go about finding the unknown half cell. The following observations were made while the cell was in operation. So what did we see? The cation ions. Immediately when you see cation ions, you are saying that this flows always to the cathode. I have overemphasized that the cation ions, they will flow, because these are positive ions. They will flow to the cathode in order to maintain neutrality. The anions or the negative ions will flow to the anode to maintain neutrality. So in this case, we are saying our cation ions from the Sol bridge. Yes, we said the ions, they move through the Sol bridge. They will move into the electrolyte of half cell A. So you can see that, oh, cation ions, they move to the cathode. So this statement is telling you that half cell A, that's where our cathode is. And you know what cathode do? We said red cat, which is gaining of electrons. The reduction reaction will take place, which means we are looking for a situation where Ag plus will gain electrons to form Ag. That's what that information is telling you. It's telling you to say at the cathode is a reduction, which is gaining of electrons. And if you can go to the table 4b or 4a, you will be able to see that Ag plus can gain 1 electron to form Ag. Now that's the reaction we're expecting at the cathode, because at the cathode there is gain of electrons. How do we know that this is a cathode? We're saying where the cation ions or where the positive ions move, that's they move to the cathode. So half cell A is a cathode. Why? Because the cation ions are moving towards it. Now let's look at Roman figure 2 there. It says the initial EMF of the cell is 0.03 volts. This one is helping you now to solve this question that we're having. To say, okay, we know EMF of a cell. EMF of a cell, initial EMF is 0.03 volts. But we know silver. So our only job now is to go and look for the silver half cell. And then we can use the formula now to find the unknown one. You see? And that's how the questions, if you look at the trends, are going. It's either we give you the two of them, or we give you the EMF of the cell and either the cathode or the anode. Then we'll ask you to identify the other one from the table. In this case, they said calculate the E value or the EMF, the standard reduction potential or of cell B. So they want to know how much is cell B. So in this question, we are simply saying identify the what is the ions there and the solution in cell B. Now, our job has been made easy. Then you need that table. You see, hence I said the table is your friend, because that's when you are saying, how will I get? You must go and look for silver ion and silver. Then we go to the table, we look for silver ion. This is our table that we have used before. And then you look for Ag. Fortunately, I got it faster. Ag plus Ag is 0,80. So you are able to go back to your question and say, okay, now I have the information that will help me to solve this issue, because I know for silver plus, we are saying for silver forming Ag, this cell, they have cell A. We are saying that the E cell is, E of that is 0,80. So you can see now you are celebrating. You write the formula E of a cell is equals to E cathode minus E anode. E cathode, you must write it in full the way it appears in the data sheet. So you'll say E cathode minus E anode, and then you are able to say E of a cell. We're given that E of a cell is 0,03. That is equals to E cathode. Our cathode, we said this is our cathode because the cations are moving towards it. So our cathode is 0,80. Then minus E anode. So we're going to find out what is our anode here. Nice question. You transpose, then you have 0,03 minus 0,80 equals to E anode. And if you use your calculator, and your calculator is using what? 80 minus 3 is 77. So that will give you 0,77 volts. So you are able to go to your table and look for 0,77 volts, and then you will have identified the substance that we have there. So you simply go to your table, you look up to 0, 0,15, 0,77 is what we are looking for. Oh yes, you're able to see that, oh, this was ion 3 plus gaining 1 electron, forming ion 2 plus. So in this case, you are able to come back here and say, okay, cell B was the anode, so it was Fe 2 plus losing an electron to form Fe 3 plus. Remember, on the anode we said there is loss of electrons. So you write the reaction going backward, because on the anode you reverse the anode. The cathode, you write it the way it appears on table 4b with one arrow. So that is our language there. Then you know already they are going to ask you one, either to write this reaction at the cathode or the reaction at the anode, and you are able to get it. So you have seen that that is the ion half cell. Now, write down the half cell for reaction cell B, which is what I just did for you there, and you are able to get your 2 marks. Write down the cell notation. You see, this issue is either will ask you to write the net or the overall cell reaction, or will say calculate the cell, write down the cell notation. And remember what we said? We said all clever learners, or you say ABC. So we're always emphasizing that so that you don't forget. It's the anode, Sol bridge, and cathode. Remember, when you get that 3 marks, you got a lot in terms of the paper. Out of 150, that is 2% of the whole paper. So it's important that you know how to write this cell notation. And then already you have identified that on the anode side, you had Fe 2 plus becoming Fe 3 plus. You see the mistake I've made there? You can't write a solid line, because 3 plus and 2 plus, they are all aqueous solution. So when they are all aqueous solution, you write Fe. So this will be wrong. You can't write a solid line between them because they have the same phase. So you must say Fe 2 plus, comma, Fe 3 plus, because they are in the same phase. And then we have discussed you can't connect your electricity, your conducting wires inside the solution. You must have an electrode. So because you have aqueous solutions, 2 aqueous solutions, Fe2 plus and Fe3 plus, you are able to say, I'm going to take platinum solid as my electrode. You see the importance of platinum? We bring it when we don't have a solid. And then you are able to show your Sol bridge, the double lines, and then you are able to go to your cathode with Ag plus on the cathode, forming Ag, and they are in different phase, and so we're writing a line like that. Look at that, how beautiful that is. And then you wrote your cell notation, you have 3 marks for writing the cell notation. So you can see that you are collecting your marks here, and then you will be able to celebrate. Now we are saying write down 2 standard conditions. You see the issue of standard condition. We are still emphasizing. Start with your temperature and your concentration, because those ones they apply to all these reactions. But when it comes to pressure, it affects when we have gases. So there's no gas here. With aqueous solution and solids, we don't have any gas. So you know definitely that the 2 standard conditions will be your temperature. You can't just say temperature. You must write it in full and say temperature of 25 degrees Celsius or 298 kelvins, and you will say initial concentration of 1 mole per cubic decimeter. Then you are collecting your 2 marks there for doing that. Energy conversion for galvanic cell. Remember here we're producing electricity. So we are saying from chemical energy to electrical energy. In full, please, you write energy conversion is from chemical energy to electrical energy. Then look at how many marks you are collecting. Now, in this statement, they say the concentration of Ag plus. Remember, Ag plus is the one that is decreasing. Remember, Ag plus is reacting with the electron to form Ag solid. So you are expecting that the solid Ag is increasing in mass because there's more solid Ag that is being formed when Ag plus accept or gains electrons at the cathode. So Ag plus is increasing in mass. What is happening to the concentration of Ag plus? Is decreasing because it's busy reacting with the electrons there to form Ag plus. So you will see that, okay, the concentration of Ag plus cannot be that 1 mole per cubic decimeter that we started with. The concentration is decreasing. And as the concentration decreases, the EMF of the cell will decrease. So if you increase the concentration of Ag plus, it simply means that now you are increasing the EMF of the cell. Hence, you will choose increases there as your option, because when you increase the concentration of the aqueous of the electrolyte of the solution there, which is Ag plus, you are increasing the EMF. So I hope you got that and you are happy with the answer that we got. Now, as we move, that is your marking guideline. We have discussed all this, and I hope you are happy. We're able to get our 0.77. We're able to write the half fraction that takes place at the anode. We're able to say platinum must be there because Fe2 plus and Fe3 plus are all aqueous solutions. Remember, I said you can include the concentration of the solutions there. And then the temperature, we said, is 25 degrees or 298 kelvins. The concentration, initial concentration, we said, is 1 mole per cubic decimeter. And then you are able to write that. And then we said energy conversion for galvanic is from chemical energy to electrical energy. And they said, when you increase, I want you to have that in your mind and let it be part of your understanding that when we increase the concentration of the ions in the cathode ions, when we increase those concentration of the ions, metal ions in the cathode, we are going to increase the EMF of the cell. Now let's go to Northern Cape and look at this paper. They said consider the following chemical reaction. So we're having lead again, Pb forming Pb2 plus, just forgive me, there is Pb2 plus and then plus 2 electrons. So you're able to see that we have lead is losing electrons, and we said loss of electron is oxidation, which means Pb is our reducing agent, and our reducing agent is oxidized to Pb2 plus. You can see that, and we are having here gaining of electrons, which is a reduction, which is our oxidizing agent, which is now reduced. So those are the half fractions that were given. Now, which one of the following combination is correct for reaction X and Y? So the first column there were given reaction X. For the second column were given reaction Y. So we were looking for the correct. You see, it's very much important to know that we are looking for the correct ones, which means the other three are incorrect. Now let's look. Number A, they are saying Pb is reduced, which is not correct because Pb is oxidized from Pb to Pb2 plus. Its oxidation number has increased. So this is wrong. We don't have to go any further. Number B, Pb is oxidized. Correct. Pb is oxidized. and they are saying H plus is reduced. Interesting. Let's check. The oxidation number of 4H plus here, we're given 4H plus like that. Its oxidation number is +1. And then if you go to 2H2O, 2H2O, the oxidation number of hydrogen is still 1. So the oxidation number of oxygen did not change. It remained the same. So it cannot be reduced when it remained the same. Hence, we are going to say this is wrong because H plus is not reduced. It remains the same. Now, let's go. Lead, we have agreed Pb is oxidized. It means it has increased from Pb to Pb2 plus. We agree with that statement. But the next statement says O2 is reduced. Let's go and check. Is O2 reduced or what happened there? So you can see that on the reactant side, we have O2 there. And you know that for diatomic molecules like your H2, your Br2, your Cl2, if they are like that, their oxidation number is 0. So the oxidation number is 0 for O2, but on this one, remember group 16, oxygen is group 16, which is -2. If it's in a molecule like that one, the oxidation number is -2. So you can see that oxygen moved from 0 to -2. Hence, we're saying O2 is reduced. So you're able to know that the correct answer is number C, and you choose it with confidence, and you are able to know that you are doing the right thing. So that was the paper from Northern Cape, the multiple choice. Now we're going to the actual question. And if you look at this question already, they say the diagram below represent a galvanic cell. Immediately when you say galvanic cell, you know we are converting chemical to electrical energy. And remember, we're saying this is a spontaneous reaction. It's spontaneous because no energy is added. So we are producing energy. Hence, we say this is exothermic reaction. Galvanic cells are exothermic reaction. So if we say define galvanic cell, you will tell us about energy conversion to say they convert chemical energy to electrical energy. Under standard conditions, you see the issue of standard conditions. Look at how many question papers that we did that we're asking you about standard conditions. So you can't make a mistake of going to the exam room without understanding what are the standard conditions. And remember the order, we said start with the 2, which is concentration and temperature. Only if we have gases will include pressure. So it's important that you have that. And then we are given the net cell reaction as 2Fe3 plus 3 magnesium, 2FeS plus 3 Mg2 plus. Let me tell you something. If you look at that overall or net cell reaction, I already indicated that at the left or at the reactant side, we are given a stronger oxidizing agent plus a stronger reducing agent. So the two that we are having here, the other one is a stronger oxidizing agent, the other one is a stronger reducing agent. And if you remember, we said we go to the table to check which one is a stronger reducing agent, which one is a weaker reducing agent. So this is between magnesium and iron. And if you were to move to the table quickly and look for magnesium, you will see that magnesium is at the top there. It's at the top there. That is your magnesium there. So meaning that magnesium is a stronger reducing agent. We're comparing it with iron. Please, learners, always be careful, because when you look for iron, there are many ions that we have. And if you check in our question, the ion that we're talking about is iron 3 plus and ion 0, the ion that is not having anything. So please be sure that when you go to the table, you choose the right ion, because you can be excited and choose a different ion, and the whole question now becomes a different question. So the ion that we are looking for is this ion with a 3 plus and ion with no oxidation number. So that is the one, and that is negative 0.06. Now, maybe I can show you another method of understanding or doing this type of question. When you are given two substances that appears in the table with no using table 4b, remember galvanic cell question 8. We are given Mg2 plus 2 electrons. I'm just copying what appears on the table. Maybe you'll see this one much better. And then we're given Fe3 plus 3 electrons, forming Fe. And we said this one is negative 0.06. The other one is negative 2.36. So I hope you got that. You got that correct. So the main thing that you have to deal with is a question of saying this, the one at the top of that table. That's where your anode is. That's your anode. The one at the bottom of your table, that's where your cathode is. So you are able to know that the one with the, remember this table is a table of standard reduction potential, which means potential stands for ability. Reduction stands for gaining of electrons. So which means this table is a table of ability to gain electrons under standard conditions. So when you read that table, it must have meaning to you to say which one between Fe and Mg, which one has more ability to gain electrons. And if you check always on table 4b, this one, the very same one, your reducing agent that is at the top there on the right, that is the one that will lose electrons, and the one at the bottom so will be is where you will find your strongest oxidizing agent. So with no doubt, you can just do your Z there. I like to doing that. Just do a Z. So you can even do that Z on the table to say, okay, what we're given here is Mg like that. Then I make my Z like that, a big Z like that. You see, with arrows, my Z must have arrows. So this Z shows you that the first one, this one at the top there, is going, when you write it going backward, because it doesn't have a higher ability to gain electrons. So it must lose them. Hence, now when you make your Z, it shows you that the first one, we're going to write it as Mg, forming Mg2 plus 2 electrons. And the second one, we write it the way it appears, but with one R. We don't change it, hence the Z is going that side. So it's able to say this one will be Fe3 plus 3 electrons, forming Fe. So you are able to do that. And remember, you can say this one at the top there is A, and the one at the bottom is C. So always when you are counting your alphabets, they will always start from A, B, C, D. So the anode is that one at the top and the cathode at the bottom. So already you will have seen that this is your anode, magnesium is your anode, and iron is your cathode. Don't make a mistake of thinking that your cathode is Fe3 plus. Remember, a cathode, the electrode must be solid. In this case, our solids here is iron. So we have iron and magnesium as our electrode. So those two are our reducing agents. And then we're having Mg2 plus and Fe3 plus as our oxidizing agent. And when it goes to issue of strength, we said when you go down the group on the left, you are increasing the oxidizing ability. You see these arrows all the time. So you can see that iron 3 plus is a stronger oxidizing agent than magnesium 2 plus. On the right, you are having your reducing agents, which means that magnesium is a stronger reducing agent than iron. And if you are stronger, it means magnesium must lose electrons. And then iron will be formed in that case when iron 3 plus gains electrons, because iron 3 plus is a stronger oxidizing agent. So already we have written there the reaction in the anode, which is your loss of electron, which you said is oxidation, pardon me. And then we had our gaining of electrons, which you said is reduction. So you are able to see now that, okay, loss of electrons, when I'm doing the Z method, you write the Z going backward, you're able to say that is my anode, it reverses. But my cathode remains because it has a higher ability to gain electrons. So my cathode will always be, where cathode is, there will be reduction, reaction, or there will be gaining of electrons. Please, learners, I want to emphasize this, that it's not the cathode that gains electrons, because it is the ion. Remember, our cathode here is ion, ion Fe. Fe is our cathode. It's not Fe that is gaining electrons, but it's Fe3 plus. It's the ion of that particular metal in the cathode that is gaining electrons, so that you don't have that, because sometimes in the multiple choice questions, we're able to ask you which one is your oxidizing agent. then learners will say ion. No, ion is not an oxidizing agent. Remember, the oxidizing agent are on the left of the table, and you follow the arrow. The one that where the arrow is pointing is the strongest. In this case, our strongest oxidizing agent is Fe3+. Our strongest reducing agent is Mg. So I'm hoping we are moving together, me and you. So we're able to write the loss of electrons. So we can say magnesium is our reducing agent, and we can say Fe3+ is our oxidizing agent because Fe3+ is reduced. And we can say magnesium is our reducing agent because magnesium is oxidized. So you're able to get that. And then from there, you can even use this to calculate the EMF of the cell, to say the EMF of a cell is E cathode minus E anode. I'm still emphasizing you write the formula the way it appears in the data sheet so that we don't have problem. Now your E cathode, we have agreed that minus 0.06 is your cathode, and then your minus, don't forget, is minus 2.36. That is your anode there. And then you are able to say, okay, we have a positive 2.36 minus 0.06. I think that is giving you 2.30 if my math is doing well. And then you are able to get that, and it's spontaneous. And definitely this is the question that you are going to get in the question. So always then this method helps you to identify the cathode and the anode faster. To say when I go to table 4b, I will look for the two that I'm given on the equation. I will write my Z. The first one is my anode, the second one is my cathode. And my anode, I will write it in reverse. My cathode, I will write it as it's going forward. And I'm able to use that information as well to calculate the EMF of the cell. And I'm able to get my answer. And if we go back to the question, you will see that whatever that we were doing is going to assist you. So the energy conversion we have said for the galvanic cell is from chemical energy to electrical energy. And said the two standard condition will be the initial concentration of 1 mole per cubic decimeter and the temperature of 298 kelvins or 25 degrees Celsius. You will write temperature and concentration in full. The electrode which acts as the cathode, we have already indicated that is ion. That is ion, because the ion 3+ will gain electrons to form ion. We said already magnesium is a stronger reducing agent, so it will lose electrons to form magnesium 2+. So give a reason, because we said the reason here that your ion 3+ is going to gain your electrons and form ion there. Now write down the oxidational fraction. You're just collecting marks. Remember, on the table I've written all this when you're using that set method, so you're able to just write the oxidational fraction like that. The cell notation, remember, on the cell notation already, when you know that okay, this one is on the anode, so on the anode, we are starting with, we said all clever learners, so we're saying now on the anode we have Mg forming Mg2+. I always get learners who are asking, do I have to balance the reaction when I'm writing the cell notation? I said no. Even if you didn't show the 2s and the 3s, you will get your marks. And then your Soul bridge, and then you can indicate the concentration of Mg2+ as 1 mole per cubic decimeter. And you had Fe3+ here, that is becoming Fe. So this is the cathode, this is the anode, this cell notation. And always you can see that cell notation has 3 marks. So cell notation, overall cell reaction, very much important because it carries a lot of marks. And then the name of the component responsible for electrical neutrality of the half cell. Remember, this one we said is the Soul bridge to maintain neutrality. So you will say cell bridge. Calculate the EMF of the cell, which is what we did. Here, we were able to get that answer of 2.30 volts. So you're able to do that, which is the same as what is given here. So you can see everything we've done, and we've done correctly, and you're collecting your marks. Remember, 15 marks, that is 10% of your paper. If you get questions like those and you are able to answer all of them, and then we know that we are prepared and we are ready to move. This question taken from Eastern Cape. Learners were given now the cell notation. They were given a cell. You see, cell notation, overall cell reaction. Those very important because we can use them to give you the question as well. So already you know all clever learners. So you say all clever. So you are able to see, no, this year we're having the anode, which means at the anode, aluminium will lose electrons. Aluminium will lose electrons. That's what happens at the anode, will lose electrons. But on the cathode side, you are having your permanganate ion and Mn2 plus, and they're all aqueous solution. Hence, we put a comma there, emphasizing that again. And we look for platinum because we need a solid as our conduct. Then we put the platinum that side. Now, which one of the following occurs at the cathode? So at the cathode, we know this is what is happening. Is MnO4 minus forming Mn2 plus. So now at the cathode, we gain, we don't lose electrons. So if we check here, you can see that the electrons are on the product side, which means this is loss of electrons. And this happens at the anode. So this is wrong. On the cathode, we don't lose electrons, which means now we gain electrons at the cathode. So your obvious choice is number B, because that's where we have gaining of electrons. Then you collected your marks and you are able to move. So that is good. This one from Western Cape Metronaut, the cell notation again. So cell notation, overall cell reaction. Please, this will definitely help you. They are saying now a bulb connected across the two electrodes initially glows brightly. So we're having a nickel 2 plus and silver ion silver cell. So it's the nickel silver cell that we're having. They're saying initially the bulb is glowing very, very much. Remember, nickel on the anode is losing electrons, and Ag plus on the cathode is gaining electrons. So obviously, as Ag plus is gaining electrons, its concentration is decreasing. And when I've emphasized that when the concentration of the ions in the cathode are decreasing, the EMF of the cell will decrease. So they're asking, after some time, the brightness of the bulb decreases. This is because the concentration of the Ag plus in the cathode is decreasing. So you got your answer. That is number A. You see these questions, most of them you will now they become familiar because you are doing different types of questions. Now on this one from Metronaut, they decided to give you your half cells. They said the three unknown half cells under standard conditions are given in the table below. Metal X displaces Y2 plus in YSO4 minus, that is YSO4, and then solution and metal Z displaces X2 plus in that, and then that is what we have. The first question was define the term electrolyte. Remember, we said when a substance is dissolved in water, it forms ions or it forms solution, and that solution can conduct electricity. Or you can just say it's a solution that conduct electricity through the movement of ions. Use information above to answer the following question. Write down two conditions. I'm thinking where you are seated, you are tired of the conditions, but that's how much we're emphasizing them. To say always remember the standard conditions. Now, when metal X displaces Y2 plus in YSO4 solution, will Y2 plus be oxidized or reduced? You can see Y2 plus already is oxidized. So what can happen is that it must be reduced because it was oxidized already. It had the oxidation number of Y2 plus, and then what can happen to it is reduction. Now, in this statement, they are saying the following three unknown half cell standard reaction are given in the table below. So they were given, you remember. They are saying suppose that metals, magnesium, copper, and nickel replaces X, Y, Z respectively. So they are saying where you have X, you have now have magnesium and magnesium 2 plus. Where you have Y, you now have copper and copper 2 plus. Where now you have Z, you now have nickel and nickel 2 plus. That's what this question is saying. So nothing that must be a problem to you. The question is saying identify from these metals above, nickel, copper, and magnesium, a suitable pair of electrodes that will produce an EMF of 2.7 volts. Show your calculations. So this question is simply saying calculate the EMF of 2, because we only take them in pairs. Two of the in the above, which ones, when you bring them together, they will give you an EMF of 2.7 volts. That's what this question is asking for. And obviously, if you remember the order, we had magnesium, we had copper, we had nickel. So if you look on the table, you can see magnesium is minus 2.36. And then they are expecting you to get an answer of 2.7. Don't forget, we want the two that will form 2.7 volts. So you have 2.36. And then when you go to copper, copper is 2, copper 2 plus 2 electrons is 0.34. And if you check, if you were to add 2.36 for the sake of time, plus 0.34, you can see if your math is correct, it will give you 2.7. So you can see that that is the magnesium copper cell, but they said show it through the calculation. So you are able to say, okay, E of a cell will be equals to E cathode minus E anode. So you're able to say, okay, this one, the anode, obviously at the top of the table 4b. So you know that your magnesium is the anode, your cathode is 0.34. So you'll have 0.34 minus 2.36, and that will give you 2.7 volts. And you are able to get that answer with no problem. I hope you are getting used to how to use the table and how to go about it. That's what we have done there to show you the answer in the marking guideline. Now, with this remaining time, we're going to focus now on electrolytic cells. We do 4 electrolytic processes, electrolysis processes, which is decomposition of copper chloride. I want you to have an understanding, which is breaking down, to decompose. We are breaking down copper chloride. So in this one, we want to form copper and Cl2. Just have that in your mind. And if you want to form copper and chloride and Cl2, it means these are the 2 reactions that we must have as our products. So when you go to the table, you're just looking for 2 reactions that forms copper and Cl2. And those are the 2 reactions that we expect you to understand in terms of this topic. So I'm hoping you have it in your mind to say this is what we want. Because if you check on the table, you will have seen that if you have your table there, you will see that the copper is given on the table as copper 2 plus 2 electrons forming copper, and then that is positive 0.34, and then you are having your 2Cl minus, that is a negative. I'll check. You have your Cl2 plus 2 electrons forming 2Cl minus, and you are simply looking for 2 reactions that forms copper and chlorine, which means the forward reaction of this one forms copper, which means here you will write your arrow forward because it will form copper. And on this one, you will write the arrow backward, which means on the anode, you'll have 2Cl minus forming Cl2 plus 2 electrons. On the cathode, you'll have copper 2 plus 2 electrons forming copper. And that's what we are expecting of you to understand. Now, on the electrolysis of concentrated sodium chloride solution, on this one, we are saying now, yes, we have seen on the anode, because we are having sodium chloride, and you have done what we said we call hydrolysis when you're doing your acids and bases. And we said, okay, when you put a salt in water, it will ionize, which means when you put sodium chloride in water, it will form sodium plus, chlorine minus. Don't forget, it's in water. So there is water, there is chlorine minus, there is sodium plus. That's where the competition is. And we are saying this one, the halogen, will always be at the anode. Don't forget that. Your chlorine will always be at the anode. So you know the reaction for the anode already is 2Cl minus forming Cl2 plus 2 electrons. Now, the question is, will the sodium plus accept electrons, or will the electrons be accepted by water? And you will see that it is 2 water that reacts with the 2 electrons to form the hydrogen ion and the OH minus, the 2OH minus. So please don't forget that, to say at the anode, if we have chlorine in these 2 processes, which is decomposition of copper chloride and electrolysis of concentrated sodium chloride, Cl2 will always be formed at the anode. So that one, have it in mind. So you know that at the anode, the reaction remains the same. Is this one and that one for the two reactions, for the decomposition of copper chloride and electrolysis of concentrated sodium chloride. At the cathode of the copper one, it is the copper 2 plus that gains electrons, which means copper 2 plus is a stronger oxidizing agent than water. Remember, in both reactions, there is water. So copper 2 plus is a strong oxidizing agent than water. It will gain electrons. In this case, water is a stronger oxidizing agent than sodium plus. That's why water will gain electrons, not sodium plus. Please don't forget this. This is a question that even if we check, many provinces are asking this type of questions. Now, when it comes to electroplating, I want you to move with me here. When it comes to electroplating, what we are saying that we'll have the metal and the metal ions. For example, let's say our metal is silver. So you'll have silver ions and silver. If you check the statement, we'll say we want to plate a spoon, which is an object, with that width is what which reaction will take place. And if we say with silver, so it means we're having silver ions and silver. Now, the understanding that we want you to have is this one. During this process, the width part, if we are electroplating with silver, it means the only reaction that we're having, if you go to the table, you will look for silver ion, you will get silver ion given like this. On the object side, there is no reaction except plating. That is, it's like when you are painting something, a wall. The wall is not doing anything. It's just waiting for the paint to be plated on the wall. That's what we are doing. So you simply write your Z on that one reaction. Remember, we're writing the Z on the two, the anode and the cathode. Now you simply write the Z and say the first reaction which reverses is happening at the anode. The second reaction that is going forward, it's happening at the cathode. So it means on the anode side, you know that it will be silver. It starts from here. It will be silver forming silver ion plus an electron. On the cathode side, you are writing this reaction the same way it appears, which is silver plus an electron. Remember, we don't want you to write two arrows, always one arrow. So you did that question and you understand electroplating, and you are saying the concentration of the electrolyte remains constant. It remains the same. Why? Because you can see that the rate of oxidation and the rate of reduction remains the same. So we have equal rates of the rate of oxidation is equals to the rate of reduction. So you're just doing that. The same with purification. When you say purification of copper, what that statement is telling you is that we are having a reaction of copper 2 plus 2 electrons forming copper. You will do the same. You will write your Z. And you are saying the first reaction is on the anode, the second reaction is on the cathode. So you are able to say, okay, for on the anode, copper will lose electrons. You are going backward. Copper will lose electrons. And on the cathode, copper 2 plus will gain electrons to form copper. And that's how purification occurs. Remember, we can change, we can say we want to purify something else. It's still fine, whatever that we are purifying, but you will take that reaction, the way it appears on the table, that reaction of what you are purifying, and then you are able to make the Z and show that the anode one is going backward and the cathode one is going forward. We are done in terms of these four processes. You are able to do that. I hope it will help you as we answer some questions. But before we start this section, we're saying don't panic. What are we saying? We're saying remember on galvanic cell, we're saying the positive one is our cathode, the negative one is our anode. In this case, when we say don't panic, we're saying positive now, we call it anode. Negative is called cathode. Remember now, this is electrolysis, which is a process where electrical energy is converted to chemical energy. Please, learners, don't make a mistake of confusing this with motors and generators in paper 1. We don't talk about mechanical energy here. We talk about chemical energy. And then we're saying don't panic. Positive is anode, negative is cathode. So we're able to move. We can use the table in order to do some of the questions, and then as we move forward, free state paper, what is the energy conversion in electrolytic cell? So you are able to say, okay, this one is from chemical from electrical to chemical. We are using electricity, hence we have a power source. You can see we have a power source. That shows that this is a non-spontaneous process. It's a process that is forced. We're using electricity to force the positive anode to lose electrons. Remember, a positive doesn't want to lose electrons, but because of the electricity, the direct current that we're using is able to take the electrons from a positive anode and give those electrons forcefully to the negative cathode. So you are able to say that, and then we're saying it's from electrical to chemical, it's non-spontaneous. The simplified diagram below represent electrolysis. You can ask yourself, what is electrolysis? Electrolysis is a process. Don't forget, electrolysis is a process where electrical energy is converted to chemical energy from E to C. On the name there, it can remind you that is 2 marks for the first question. Which electrode is the anode? Remember, we talked about this to say on the anode, that's where our chlorine will be formed. And we said the positive is our anode. Positive is anode. Don't panic. Positive anode, negative cathode. So you see that the bigger one is a positive, the smaller one is the negative. So you're able to look at that, and we're saying which electrode is the anode, right? Only X or Y. So you're just looking for positive because we said positive is anode. You see that panic, it gave you 1 mark there to say the positive is where X is. So you're able to say, oh, anode is X. Now, write down the half reaction that takes place at electrode X. You know that where chlorine is positive anode. We said on that one, the 2Cl minus, the Cl2 is formed. So you just write the reaction that forms to Cl2. So you're able to say this is the reaction that takes place at X. At Y, remember we said sodium plus is not a stronger oxidizing agent than water. So water is the one that will gain electrons. We just talked about that now. So you're able to write 2 water plus 2 electrons forming the hydrogen gas and the 2OH minus. Look at the marks we are collecting. 2, 2. We have 4 marks for that. A current, you see now, you have seen that we're evolving, we're moving towards geometric calculations now. And you see that our examiners now, they are asking us to do questions that involve the current and the charges and the molar volumes and the number of particles, all that grade 10 and 11 information, you are able to utilize it. Look at 9.4. It's saying a current of 0.5. Immediately when you see current, you know it's the rate of flow of charges. I equals to Q over T. That's what comes to your mind. It's applied over a period of 5 hours. Oh, you know, we have current is 0.5. We have time is 5 hours. Remember, our time has been seconds. And to do that, to convert, remember 5 hours, how many minutes in an hour is 60. How many seconds in a minute is 60. So you'll say 5 times 60 times 60, and that will give you our time that we're having, and that will be multiplied by 0.5, which is our current. So that's what we are expecting. But look at the question. The question is saying calculate the volume. You can see that whatever information we have is not talking about volume of chlorine gas at standard temperature and pressure. We have standard conditions there that is formed during this time. So you can see that immediately when you say volume, you know when you say STP, the equation that comes to your mind is N equals to V over Vm. And that tells you that you need to first know the number of moles. You must know the number of moles. So remember, you were able to calculate the charge. So this is a process where you know that N equals to Q over QE. And you know that the other formula N equals to N over NA. So all these which I'm writing on the board, these are the pieces of puzzle that you are going to join together in order for you to answer this question and get that 6 marks. So I'm hoping that you will be able to do that. As I indicated, the first step will be for you to write the formula I equals to Q over T. You substitute, and then the 5 times 60 times 60 gives us 18,000. You multiply that by 0.5, it gives us 9,000 coulombs. So we got the Q. Immediately when we have the Q, we look for the formula, and then you know that Q, which is 9,000, over charge of an electron, which is negative 1,6 times 10 to the power minus 19 with a positive charge there. Don't write it as a negative, just write 1,6 times 10 to the power minus 19. And then you're able to say 9,000 divided by that, you get the number of electrons. Please, learners, don't think that this n, usually I will just write bigger ones to try and differentiate from the other one. Don't think that this n you are calculating here is the number of moles. No, it's the number of electrons. So immediately when you got your number of electrons, which is the same as number of particles over Avogadro's number, that formula n equals to n over Na, you are able to get your number of electrons in this case, and then you use the number of moles of electrons, you are able to use n over Na, which is the number of particles, which is in this case the number of electrons, which is 5,625 times 10 to the power of 25 divided by Avogadro's number, and then you are able to get 0,093 moles. And then you are able to say now the mole ratio there. We are saying that for the chlorine, we have those the number of moles is 1:2, and then we are able to divide that by 2, then you get 0,0465. From there, you can now use n equals to V over Vm, which now we know that our n we've calculated is 0,05465. And then from the data sheet, our molar volume, your 22,3, 22,4 in this case, and then you multiply that, you get your volume as 1,04 cubic decimeter. I'm hoping that you will continue to practice questions related to this one so that we don't have problems. You are able to do this stoichiometry. It's just they just round around the same. It's not something that is different. Now, this question is saying which one of the half reactions below will be the main reaction at the cathode during the electrolysis of concentrated sodium chloride. Already we said chlorine Cl2 forms at the anode. So, and we said sodium plus is not a stronger oxidizing agent than water. So definitely it must be water gaining electrons to form that, which is number C. I'm trying to be fast so that we have done this question before, you have seen it. And this was the paper from KZN. Define the term electrolyte. You see, you are still telling us here it's a solution that conducts electricity through the movement of ions. Which electrode, M or N? I like this question because they gave us the graph. So you can see that there is now for mass of electrode M, you can see that it's increasing from 12,52 to 17,85. And we said when we started that the mass that increases is the mass of the cathode. So definitely M is on the cathode, which means M is on the cathode, which means N will be our anode. How do we know that M is the cathode? Its mass is increasing. There is increasing mass, which means we said positive is anode. So the bigger one is like that, and the smaller one is like that. So you can even show it like that to say this is negative, this is positive, because you are saying positive is anode, negative is cathode. So the problem becomes even much easier for you. You can see now is electroplating. They are saying electrolytic cell used to electroplate an iron bar with. Remember what I said. When they say with, all you have to do is say the only reaction that is taking place here is the copper 2 plus 2 electrons. This is how it appears on the table, forming copper. I said you write your Z and you say at the anode we go backward, at the cathode we go forward. So you're able to say the first question was which electrode M or N represent the iron bar. So the iron bar must be here at the cathode, will be your M. Why? Because it's the one that is being electroplated with your copper, because it's increasing in mass. But it is observed that the concentration of the electrolyte remains constant. We talked about this to say during electroplating and purification of these metals, the concentration of the electrolyte, as long as we're using this one reaction and saying the first one goes backward, the second one, anode goes backward, cathode goes forward, we said that the concentration of the electrolyte remains constant because the rate of oxidation is equal to the rate of reduction. Now, as I move towards the completion of our lesson, to say in this question now, they're saying calculate the value of X. So you can see that this question is not going anywhere. Calculate the value of X as shown on the graph if a constant current of 1,5 amperes is passing through the cell. So already you can see that current is given. Current is 1,5 amperes, and you know when you have current, you can find the charge because I equals Q over QE, and then you are I equals Q over delta T, which is this one, and then you can go to number Q over Q charge of an electron. I mean Q over T as our first equation, and then you are able to get your charge. But in this case, we want T. We only have this, which means we must first find Q. And you know that the number of moles, the N equals to Q over Q will come into place as well. And these are the formulas that you are going to use to be able to calculate this question. So the main thing here that I want to emphasize as we conclude is to say you could have seen already that our mass increased from 12,52 to 17,85, which means now this change in mass here, we can use it to calculate the number of moles if we want to solve that problem. Because the number of moles, once we have the number of moles, then it will help us in order for us to finish this type of question. In this case, you will have found the difference in the mass. You will have found the difference in the mass divided by the molar mass of your copper, which is 63,5. And then you do the mole ratios there, and then you're able to get that the number of moles is 0,168. And then using that formula, N equals to Na over N over Na. The formula N equals to N over Na. You use that one. When you substitute, you are able now to get your N, and then you can use the Q, the charge as well. Then you are able to do that and calculate your time. I know that we have been trying to be fast in terms of this question, but as I conclude, I would like to say to yourselves that the main thing is that we were given the mass as we started with this question. And where did we get the mass from? We got the mass from the change in the table of our cathode. And then we are saying that you will find that change, you divide it by the molar mass in order to find the number of moles of those electrons. And then we are saying there are 2 electrons, hence that, then you use that mole ratio to get the number of electrons. And then after that, we are able as well to go and find a number of moles equals to number of particles over Na, and then we have Na and we have our N there, and then we are able to use that. Then we go again, we look for the charge as we've done in the other question. We got that our charge is 16,176 coulomb, and then we can now simply calculate the charge, which is I times delta T. In this case, the charge was 16,176 equals to 1,5, which is our current that was given initially. And then we're able to calculate our time as being the last one here. I won't be happy if I close this session without talking to this question of 9.5, which is our last question for the day. It says, it is observed that the iron bar is not coated with zinc. Explain this observation in terms of the relative oxidizing strength of the substance. Now, if you go to the table, for example, let me go back to the table. Yes. Now, if you check, we are having zinc and copper. The copper, the 2 plus, which is 0,34. So we're having that. And we're having our zinc, which is negative 0,76. Just take it from here because we don't have time. But I want to explain this. It says zinc 2 plus 2 electrons forms zinc. And we said this is negative 0,76. And we are saying copper 2 plus 2 electrons forms copper, which is positive 0,34. Now, the question is saying use why zinc is not the one that is formed. The thing is, now the presence of zinc, if you check on the left, we said we have oxidizing agents. And the strength of oxidizing agents increases when we go down from zinc 2 plus to copper 2 plus. On the side of this side, on the right hand side, we have reducing agents, and they increase as we go up. But this question is said use the oxidizing ability to explain this question. So you must focus on this one. Why zinc is not formed but copper? So you're going to say copper 2 plus is a stronger oxidizing agent. In full, it's a stronger oxidizing agent than zinc 2 plus. Hence, copper 2 plus will be reduced. Copper 2 plus will be reduced to copper. Hence, copper is formed. Please, learners, this question is always almost there. So I would like you to always look at that and not lose that 3 marks. If we're saying use oxidizing ability, it means you'll go to the left and compare apples with apples. You can't now compare zinc 2 plus and copper. No, it must be what is on the left is the oxidizing agent that you are comparing. What is on the right are the reducing agents that you are comparing. I hope this lesson has opened your eyes and you will continue to do as many questions as possible. And without any wasting time, I will say thank you for watching this lesson. See you next time. Goodbye.